This is Algebra 2, Unit 11, Lesson 10 on the tangent function. Now, the two most important circular functions are sine and cosine. But if you recall that when we did geometry, that there was a third trigonometric function known as tangent. And there are actually three more that we will learn about in the next lesson, but we're going to look at the tangent function this lesson. So let's look at the definition of tangent through right triangle trigonometry. Okay, so tangent of theta, remember on SOHCAHTOA, tangent is opposite over adjacent. So from the angle of theta, it is opposite over adjacent. You don't use the hypotenuse at all. All right, so now that we know SOHCAHTOA, remember or recall SOHCAHTOA, let's see if we can figure out the values of sine theta, cosine theta, and tangent theta. All right, so from SOHCAHTOA, we remember that sine is opposite over hypotenuse. So if I'm from theta right here, the problem is, do we know what opposite is? Well, we can find it. In a right triangle, if this side over here we don't know, we can make this x. We can use the Pythagorean Theorem. So this will be x squared plus 4 squared is equal to 5 squared. X squared plus 16 is equal to 25. Subtract the 16, x squared is equal to 9. Take the square root, and x is equal to 3. Okay, so this side is going to be 3. So when we set up sine of theta, it's opposite over hypotenuse. Opposite is 3, hypotenuse is 5. Cosine theta is adjacent over hypotenuse. Adjacent on this one is going to be 4. Remember, adjacent is the side it's sitting on, but not the hypotenuse. And then hypotenuse was 5. And tangent of theta would be opposite over adjacent, which would be 3 over 4. Okay, so that is an example of sine, cosine, tangent from a right triangle. So let's try this one. Now again, we need to know what this side over here is. So using the Pythagorean Theorem, 1 squared plus x squared is equal to 2 squared. 1 plus x squared is equal to 4. Subtract the 1. X squared is equal to 3. Take the square root of both sides. X is equal to the square root of 3. And we'll just leave it as the square root of 3 for right now. Okay, so sine is opposite over hypotenuse, which would be the square root of 3 over 2. Cosine of theta is adjacent over hypotenuse, which is a 1/2. And tangent is opposite over adjacent, which would be the square root of 3 over 1, which is just the square root of 3. Okay, now you probably could tell me right now what the theta angle is for this. If sine of theta is square root of 3 over 2, and cosine is 1/2, that's a 60-degree angle. But we'll get to that later. Notice that we can have missing sides of a right triangle and still use the Pythagorean Theorem to find these ratios, which will involve radicals and thus irrational numbers. Now, just as we did with sine and cosine, you can also define tangent in terms of the unit circle. So here is the unit circle diagram. Remember, unit circle means that the radius of the circle is going to be 1, and then each coordinate is going to be x comma y. All right, so if x comma y represents a point on the circle, how can we define the tangent function in terms of this point? Well, remember that tangent of theta is opposite over adjacent. So if I'm looking at this angle right here, opposite would be y, and then adjacent would be x, because the distance from here to here would be y, the distance from here to here would be x. Opposite y, adjacent is x. Okay, so given how we define sine and cosine, how can we define the tangent function in terms of sine and cosine? Well, what coordinate did we say was the y-coordinate? Well, with the y-coordinate we said is sine. And the x-coordinate is cosine. So tangent of theta is equal to sine over cosine, because this is the y-coordinate and this is the x-coordinate. So tangent can also be defined as sine over cosine or y over x. So the definition of tangent in terms of sine and cosine is tangent of theta is equal to sine of theta over cosine of theta. So we can use the unit circle and the definition of tangent in terms of sine and cosine to find the value of each of the following. So we don't want to leave any complex fractions, which means fractions inside of fractions. Okay, so let's see if we remember our values for sine, cosine, and tangent. All right, just to remind ourselves, sine of 30 is 1/2, which would equal the cosine of 60. Sine of the square root of 3 over 2, sine of 60 is the square root of 3 over 2, which is equal to the cosine of 30. And then sine of 45 is equal to the square root of 2 over 2, which is equal to cosine of 45. So they're the same. So those are our values from our unit circle. Okay, so all we have to do is figure out what we have for this. So the tangent of 60. All right, so that means it's going to be the sine of 60 over the cosine of 60. All right, so the sine of 60 we know is the square root of 3 over 2. And then the cosine of 60 is 1/2. All right, so it's this divided by this, which is square root of 3 over 2, times, because we're going to do the reciprocal, 2 over 1. Cancel, cancel. It's the square root of 3 over 1, which is the square root of 3. Okay, so the tangent of 60 is equal to the square root of 3. Okay, tangent of 45. All right, so it's going to be the sine of 45 over the cosine of 45. All right, the sine of 45 is the square root of 2 over 2. The cosine of 45 is also the square root of 2 over 2. So we're dividing the same thing by itself, so it's going to equal 1. So the tangent of 45 is 1. All right, the tangent of 150. All right, now let's think about this. Where is 150 degrees on the unit circle? Well, 150 degrees would be in the second quadrant. Okay, and what would be its reference angle? Well, if this is 150, the reference angle would have to be 30. So we want to use the sine of 150 over the cosine of 150. Now, using the reference angle of 30 degrees, in the second quadrant, is sine positive or sine negative? Well, remember A, S, T, C. Sine is positive, which means cosine is negative. So the sine of 150 is equivalent to the positive sine of 30, which is 1/2. And then cosine of 30 would be square root of 3 over 2, but we're in the second quadrant, so it would be negative square root of 3 over 2. All right, so if I divide this by this, I'm going to multiply by the reciprocal. It's 1/2 times negative 2 over the square root of 3, which will be, these will cancel, leaving negative 1, which is negative 1 over the square root of 3. Now, we don't usually like to leave the square root of 3 in the denominator, so I'm going to multiply this by the square root of 3 over 3. Because that'll cancel out the square root, leaving 3. So this is negative square root of 3 over 3. And that is the tangent of 150. Okay, last one, tangent of 180 would be the sine of 180 over the cosine of 180. All right, now remember, 180 degrees would be on the unit circle right here. What would be the coordinates? Well, if this is going to be the coordinates, this would be the coordinate negative 1, 0. That means sine of 180 will be 0, cosine will be negative 1, so tangent of 180 will be 0. Okay, so you can see how we can use sine and cosine to figure out the values. That's really helpful if you know your values for each of the quadrants as well. Now, there is one thing you have to be careful of when you're doing tangent. Because the tangent function involves division, we have to divide sine by cosine, there is a chance it could be undefined. Okay, so let's consider the angle of theta equals 90 degrees or pi over 2 radians. Okay, so remember with our unit circle, 90 degrees is right here, so this would be the coordinate 0, 1. Okay, so what would be sine of theta? Well, sine of theta is the y-coordinate, so that would be 1. Cosine of theta would be the x-coordinate, which would be 0. Okay, so why would the value of tan 90 be undefined? Well, remember that tan of 90 would equal the sine of 90 over the cosine of 90. Well, sine of 90 we said is 1, cosine of 90 is 0. Well, you divide by 0, that is undefined. So you can't divide by 0 because the cosine of 90 is 0. That makes this undefined. So you cannot have tangent of 90. It's an undefined term. If you were to graph the cosine or the tangent graph, it actually has an error right there. That is called an asymptote. It comes very, very close to 0, but will never actually reach 0. Okay, at which of the following angles is tangent undefined? So where we're going to get cosine or 0 in the denominator. Well, let's think about this. All right, we'll see if we can figure that out in the next lesson. On a final note, it is interesting that if we know sine or cosine of an angle in the quadrant of the angle, we can find the other two missing trigonometric values pretty easily. Okay, so for exercise 6, determine the value of cosine theta and tan theta if sine of theta equals 5 over 13 and the terminal ray of theta lies in the second quadrant. Okay, so in order to figure out cosine theta, we have to use the Pythagorean identity. Remember, that is cosine theta squared plus sine theta squared will equal 1. That is your Pythagorean identity. Okay, so if I plug in sine theta, I can find cosine theta. So cosine theta squared plus 5 over 13 squared, because that's sine of theta, equals 1. So cosine theta squared, 5 times 5 is 25, 13 times 13 is 169, is equal to 1. All right, now solving, I'm going to do 1 minus 25 over 169. All right, if I grab my calculator, I do 1 minus alpha key 25 over 169, and I get 144 over 169. So cosine theta squared equals 144 over 169. Now I'm going to take the square root of both sides. So cosine theta is equal to plus or minus, because when you take the square root, there's two answers. Square root of 144 is 12. Square root of 169 is 13. All right, now, since cosine is either positive or negative, we are in the second quadrant. So in the second quadrant, cosine is going to be, if we have ASTC, cosine will be negative in the second quadrant. So cosine theta, in this case, will equal negative 12 over 13. So that's the second quadrant right there. So now we know sine is 5 over 13, cosine is negative 12 over 13, so tangent of theta will equal sine, which is 5 over 13, divided by cosine, which is negative 12 over 13. So tangent of theta will equal 5/13 times, multiplied by the reciprocal. The 13's cancel. Tangent of theta is equal to negative 5 over 12. So there we go. So if we know either one of the two, you can figure out the other two using the Pythagorean identity. Okay, so let's save exercise 7 for the next lesson, and then we will do the homework on the tangent function.